Over the past 6 months, we've slowly been working our way through the different calibration tools built into OrcaSlicer. Being able to quickly generate tests by entering a few parameters means dialing in filament profiles has never been easier. So far we've covered how to find temps, max flow rate, flow ratio or extrusion multiplier, and pressure advance values. In today's video, we'll be continuing with these tests and calibrating retraction. We'll go over how to set up the retraction towers, run through a few examples, and take a look at how to update these settings in your filament profile. If you've been struggling with stringing, this might be just the thing you need. So with all that being said, and without further ado, let's get right into today's video. Thank you to PCBWay for sponsoring today's video. With over a decade of experience, PCBWay offers reliable, high-quality PCB prototyping and fabrication with super fast turnaround times. Bring your projects to life with CNC machining, 3D printing, sheet metal fabrication, and injection molding services. I recently ordered 20 PCBs to use for an upcoming Nerf-inspired blaster project that I've been wanting to build for years. With as few as 5 and as many as 10,000 board order quantities, PCBWay has you covered for any project, big or small. Use the link in the description to get a $5 credit towards your first order today. Before diving into the test, I want to briefly touch on retraction. In FDM or FFF 3D printing, as important as consistent and reliable extrusion is, retractions carry a ton of weight when it comes to ensuring prints are crisp and look their best. During a typical print, there are often hundreds, if not thousands, of retractions, often happening very quickly. These are moves during a print where the extruder is pulling filament away from the nozzle instead of towards it. Due to pressure built up between the extruder and nozzle while printing, if it weren't for these quick retractions when traveling between non-connected parts, we would get lots of blobs and stringing. These retractions are also used for pressure advance to ensure corners don't have extra deposited filament, which can round out what should be a sharp corner. The primary focus of today's video is to minimize stringing. The good news is that with modern hardware often using direct drive extruders and shorter filament paths, stringing is typically pretty mild. When I started 3D printing, most machines were using a single geared Bowden extruder, which allows for more pressure buildup due to the length between the extruder and nozzle. One final note is that retraction is not the only thing that can cause stringing. Wet filament will often be much stringier than dry filament, and printing too hot also leads to excessive stringing. So if you run through these tests and are still having stringing issues, those are two other things that you'll want to check out. For our test machine, we're using the Poly Magneto X. I just got this swapped over to the latest toolhead upgrade and am working on calibrating a few filament profiles for it. The filament I'll be using is Retraction's FiberHeart PAHT, which is a high-temp carbon fiber nylon. Jumping into OrcaSlicer, the first thing we need is to make sure we have a basic filament profile. For a lot of the more standard filaments, there will already be a material profile built in that's close enough and will work, but since I'm using a bit of a specialty filament, I had to tweak an existing one. To do this, I started with selecting the carbon fiber PETG profile and made a few edits in the filament settings window. The main things I need to change are the hot end and bed temps. Using the manufacturer's provided range as a guideline, I set the hot end temp to 290 and the bed to 90 Celsius. Magneto can print up to 300°C, but to avoid any firmware safety checks or accidental early wear of hot end parts, I opted to give myself a 10 Celsius buffer. Aside from temp, you'll want to make sure that you have fan settings set correctly. For this filament, Retraction recommends no fan, so for at least this test, I disabled the layer cooling fan. Once we have our filament profile selected, we're ready to create our test. Head up to the Calibration drop-down menu in the top toolbar and select Retraction Test. In this window, we can set our starting retraction length, our ending retraction length, and how we want to step through this range. If your printer is configured with a direct drive extruder, I recommend leaving these values as they are. However, if your printer uses a Bowden extruder, you'll want to go with the larger range. OrcaSlicer docs recommend a starting value of 1mm and an ending value of 6mm with a 0.2mm step. If you run through one of these tests and see stringing throughout the entirety of the values checked, you can always expand upon it and rerun it for a follow-up print. Click OK to generate the retraction test. The test is pretty simple. It's a small base with 2 round pillars. If you zoom in at an angle, you can see the notches that represent the steps where the retraction distance will increase. So the hot end will jump back and forth laying down these rings as it cycles through your set retraction range. All that's left is to send off the sliced file to be printed. Funny enough, as much as I've dealt with my fair share of stringing over the years, I really struggled to get much stringing throughout my ranges. With this being a nylon, I did dry it in advance, but really the tower had little to no stringing. There were some fine hairs on the inside column, but that was really it. In an effort to show a better example, I ran the test with PETG as well as a silk PLA, but both tests looked nearly flawless. As I mentioned earlier, the combination of a constrained direct drive extruder, dry filament, and not printing too hot really helps to minimize or eliminate most of this stringing. However, I was determined to show an actual example where you could see a difference, so I threw on some Polymaker 95A TPU. The only additional change I made other than setting the temps for it was that I slowed down the print speed. With this being a TPU, I cut everything in half to hopefully prevent the filament from wanting to jam. Although the results can still be much more dramatic, I was at least able to see some stringing that went away as the test continued. To find the value you want to set, count the rings from the bottom up to where the stringing stops. In the case of this TPU, it looked like the stringing had completely stopped at the 7th ring, or a 0.7mm retraction distance, but I opted to go with 0.8 just to give a tiny bit of margin. Showing this Ferroni school using the same settings but different retraction distances, at a 0.2mm retraction, the print shows 10 hours and 38 minutes, while an increase to 2mm jumps the print time up to 11 hours and 41 minutes. So make sure you don't go with a larger value than what's needed. Once you've decided on your new retraction distance value, go into the filament settings and settings override. Then click length to enable it and input the retraction distance you chose from the test here. Now whenever you print with this filament profile, it'll use this specific retraction length instead of the default that's set under the extruder section of the printer settings. And that's really it. It's a fairly straightforward test and really takes no time at all. Unlike some of the other tests that we've covered, I typically only run this test if I'm having issues with a specific filament. If I'm trying out a new filament and notice a bit of stringing, I'll usually just make a slight adjustment to the retraction distance and print again, but there have been a handful of times still when using a specialty filament or playing around with some new hardware that this test has been extremely helpful. I hope that you enjoyed this video and that you are now up and running successfully with your own retraction tests, or at least feel confident in being able to do so when the time calls for it. I'm a huge fan of OrcaSlicer's built-in tests, and while many of these were possible before through some G-code editing or custom models, having them so accessible means I'm much more inclined to actually use them. Don't forget to like and subscribe for more great videos. We make a video nearly every single week, so there's always fresh content coming your way. And if you want to support the channel further, I will have links down below in the description over to our Patreon where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys.